Hi there. Welcome back to another lesson. This is the start of the CCP College Algebra course. And the first lesson we're going to talk about is going to be section 1.1, linear equations and rational equations, okay? So starting us off with just a little definition. I'll move up a little bit more so you can see that. There we go. So a quick definition, a linear equation, okay, in one variable is an equation that could be written in the form ax plus b equals 0. Okay, now why do we write it that way? You can use any variable, you can use any values to represent numbers or any integer. That's all this is. A and b are real numbers and a can't be 0 because, well, let's think about it. If a was 0, the variable x would go away and hey, you don't have an equation anymore, right? And x is the variable. So just two little examples. So the first example, 5x plus 35 equals 7. That is a linear type of equation. If you remember back in your Algebra 2 class, a linear equation is when the variable has the exponent of 1. Okay, that's the key part here. They got to make sure it's just 1 and nothing else. So for the second example, if you can see how, well, there's an x squared there. Okay, well, we know what that is already. A graph of it is a parabola, and we know that that is not linear. Okay? A second definition. A solution to an equation is a value of the variable that makes the equation true. Okay? The set of all solutions to an equation is called the solution set. So for instance, if I go back to my example up here and solve it, that would have one solution. But for something like a quadratic, we know we could have more than one solution. So we call that the solution set when you have more than one answer there. Or even just one answer, really. But I mean, again, it just comes down to what are all possibilities, all possible answers to your equation. Okay? Alrighty. So let's continue. So we have a couple properties that we're going to talk about as well. Some properties of equality. And you already know this from your, like I said, prior math courses. This is just a good little review or refresher. But most importantly, it's a way to actually see how this is written mathematically. First thing that we usually do in mathematics is we define our variables before we start explaining things. So let A, B, and C be real valued expressions. Okay, so just a nice little distinction there. Our first is the addition property of equality. So for instance, A equals B is equivalent to A plus C equals B plus C. Okay? So, you know, what does that mean? Well, think about it. If A was 10 and B was 10, then me adding some other number to each side is still going to give me the same number, right? Whether it's a 5 to both sides and they're both 15 after you simplify, or if it's a -3, okay? It's still going to be the same number. And now with addition, we also have multiplication. Property of equality, kind of the same gist of it, just with multiplication. Okay, so A equals B is equivalent to AC equals BC. Okay, so in other words, again, if these were the same number, like 10 and 10, if I multiply both sides by 3, I get 30, 30. They're still the same. Notice we don't have division on this list or subtraction. And that's very basic as to why that's the reason. For adding a negative number, that's the same thing as subtracting, right? So that takes care of the subtraction part. Multiplication, we can multiply by the reciprocal. So instead of dividing by 5, we can multiply by 1/5. Now, why do we, why even have that? Well, think about it this way. If we're dividing something by a variable, and that variable can be any number, well, if that variable was 0 per se, well, now we have some issues, right? So making multiplication a way to divide helps avoid some of those issues that we can have. Okay, so let's look at an example. Solve just a very basic equation. Okay, so here's our example right there. And your first step would be to look at this and say, okay, I'm going to distribute to both of these. That way I can actually get a solid equation and make it a little easier. So distributing the -7 to both terms, I get -7w minus 14. Then I multiply 6 to both terms, 6w minus 24. Okay, just like that. Combine terms on both sides, and then we can start moving things around. So on this side, I can combine the 14 and 15 to get -29. On the other side, I can combine the -24 and 3 to get -21. It's a preference, but my preference is to actually have the variables not be negative, okay? I think it's a little bit easier, so I'm going to add 7w over. And then add 21 to the other side, we get -8. And then we'll divide. Make sure that doesn't turn off. So we get -8 over 13 equals w. Okay, and typically we just stop there, but we can rewrite this using some proper notation. We can say that the solution set is, and then use our nice little curly brackets. We've used these before in the past, and we can actually just put the answer there. If it had more than one answer, then we just keep listing all the answers in there, in those brackets as well. Okay, so let's go ahead, let's try another example. I'll put it over here. So let's try this one. Okay, something like this. And my apologies, I think, yeah, you can still see that. I know there's a little bit of a glare. I'm going to try and shut the blinds for you. I think that, well, I guess it kind of helped, kind of didn't. All right, so what do we do here? Fractions is something that a lot of students don't like. I don't know why. Maybe just the way it was taught initially. Who knows? But how do we get rid of the fractions? Well, what we could do is look at the denominators. So look at 3, 4, and 6. Okay? And what we're going to do is we're going to find what's called just the least common denominator, or least common multiple in this, in this case, if we're just looking at the numbers. So what's a multiple that 3, 4, and 6 all have? That is the least, the smallest possible. So look at 3. Multiples of 3 is like 3, 6, 9, 12, 15. Keep going. 4 is 4, 8, 12, 16, and so forth. And then if you look at 6, you get 6, 12, 18, 24, 30, and keep going. So when you're listing all those multiples, which ones they all have, that's the smallest? And the answer is 30, okay? So what I'm going to do is I'm going to multiply both sides by, oh, actually, I don't know if you've been screaming at the TV or the computer. It's not 30, my apologies, it's 12, okay? Yeah, 3, 4, and 6 all have a multiple of 12. My apologies. Okay? Now we multiply this out. So 12 times this. Now here's what I want you to visualize. I'll write it underneath and then erase it. So if I multiply it, I get this guy. Okay? Now notice something. This 12 and 3 reduces to a 4. So it's really just 4 and then r minus 1. Okay? So we can do the rest of it in our head by doing the same principle. So 12 was over here. 12 divided by 4 is 3, so it would be 3 times the numerator. On this side, we'll do the same pattern. So 12 divided by 6 is 2, and then 2 times the remainder on top, the numerator, and then plus 24. Okay? That helps us get rid of any fractions. We don't have to worry about it. Now, I want you to be very clear on something. This is, using the multiplication property of equality. Okay, now why is that? Think about it. I multiplied both. We're saying these are equal to begin with. That these two subtracted equals these two added. And me just multiplying both sides by 12 is not changing anything. Okay, these are still equivalent to each other. So now we'll distribute, so 4r minus 4 equals minus 3r minus 15 equals 2r plus 6 plus 24. Combine some terms, so on this side I can combine the r's and numbers, so I just get r minus 19. On the other side I get 2r plus 30. I'll subtract this r to the other side. Negative 19 equals r plus 30. I'll subtract the 30 and just get negative 49. So again, we can say that the solution set is negative 49. Now, just to give you an idea, you do want to check your work, okay? And just for the sake of this video and timing of it, if I plug negative 49 back into here, it does make both of them true. All right. So let's try a little word problem. Just moving on here. Let's say I'm deciding to maybe, lease a car or buy a used car. Okay, let's have some fun with it. So Mr. McCullough must decide whether to buy a used car for $9,500 or lease a new car for an initial down payment of $3,900, followed by 12 monthly payments of $200. Okay? And this is kind of practical, right? Like if you were trying to weigh out the options like, okay, would it behoove me to do this or that? You could do something like this. Now let's establish our variables, right? As we've already discussed with some of the properties, we tell us what our variables are to help reduce any sort of ambiguity or anything that is unclear. So we're gonna let T equal the number of months I would lease it. We don't know what it is yet, how many months we want. C is gonna be the cost in dollars, okay? And then what I'm gonna do is say, set up almost like a function here, but I'll say C of T is gonna be the cost to lease a car for T months. Okay, now do you have to make it a function like do C of T? No. We're gonna be doing a lot of functions in here, so it's just kind of like, let's get used to that. So to create an equation, it would be 200 times T, because it's 200 for every month. And then plus my down payment, what was the down payment? It's 3,000, oops, don't need a symbol. 3,900. Okay, so there's my equation that represents that situation. Nothing too bad there. Now notice, we don't have a question yet. I'm gonna get to that. So here's our actual question. So how many months will the cost to lease the new car be equal to buy the new car? Okay. And actually, I probably misspoke there because we said what? Buy a new, well, not new, but a used car. So let me just put used there. Sorry about that. I want to stay consistent with the story. Well, think about it. I want to see when this is equal to the price of buying the used car, which is $9,500. So we're going to swap this out for 9,500, solve for t. So here we go. Okay. Now, to solve it, we'll subtract this 3,900 over to the other side. So we get 5,600 equals 200t. Divide, we get 28 months. So it's going to take, what would that be, like 2 years and 4 months, okay, to where leasing the car equals out to buying the used car. So something to think about, you know, like weigh the options in your head. Is that enough time, you know, or would it just behoove you to buy the used car and just kind of go away from the whole monthly payments? Okay? All right, let's continue. A couple definitions. A conditional equation is true for some values of the variable and false for other values. Okay. Hold on one moment. Sorry, my computer shut off. I want to make sure it's still recording. Okay. So if you look at this, look at the prior examples. Actually, look at this example. Okay, when are these two things equal to each other? Well, the only time they're equal to each other is when t is 28 months. So that is a conditional equation. There's only one number, one solution that works for this guy. Okay, so that's what we mean by conditional. Now, that's not the only type of equation we can have. An equation that is true for all values of the variable for which the expressions in an equation are defined is called an identity. Okay? So if it's true for everything, we call that an identity equation. So if you were to solve an equation, you get something like 4 equals 4. Okay, then anything I plug in for x, or whatever the variable is always going to work for that equation. Or if I get something like 0 equals 0, or pi equals pi, yes, that can happen. Yeah, we just pretty much say that, you know what, this is going to work for no matter what I put in for x, or what I put in for a, b, whatever it is. Okay, we have another type of equation. Okay, so we have a equation that is false for all values of the variable is called a contradiction. Okay? So in other words, you're solving the equation and then your end solution was something along the lines of like this. I'll give you an example underneath. So if you had like -3 equals -4, 35 equals 39. If you got something like that after solving it, yeah, that's not really a true statement, therefore we call it a contradiction. Okay, last little definition. A rational equation, okay, is an equation in which each term contains a rational expression. So a good example of this would be something like 12 over x equals 6 over 2x plus 3. Okay, so that has rational terms in it. But notice, you know, just because it has rational terms, does it make that a linear equation? The answer is no. Okay, if you remember A linear equation does not have a variable in the denominator of a fraction. You can rewrite this as 12 to the x to the negative 1 power, and if you remember, linear equations have variables that have an exponent of 1. Okay, so you can't necessarily classify that as linear because it really isn't. Okay? All right. Let's try some examples. Now that we went through all the vocab, let's actually see how it's applied. Okay? Solve and check the solution. Okay. Now, a little different than some of our other equations. So notice that the variable's in the denominator, but that's okay. It's not going to harm us in any way. I still want to get rid of the fractions by multiplying by some least common multiple. Okay. Don't worry about the variable right now. Look at 2 and 4. Okay. Is there a multiple that 2 and 4 both have in common? And the answer is 4, right? So if you look at multiples of 2, so it'd be 2, 4, 6, 8. Multiples of 4, 4, 8, 12. Yeah, 4 is the least common. Now tack v onto it, okay? And that's going to be our least common, in this case, denominator for this equation. So on this side, we're going to multiply by 4b, and on this side, we're going to multiply by 4b, okay? Now, same trick as the last problem that had this. I'm going to go ahead and write this out first, but as you keep solving them, you're going to be able to probably do this in your head anyway. So if I multiply 4b to this, I get 4b over 2b. 4b times this, I'm not going to multiply them together. I'm just going to write them separately for right now. And then 4b times 1 is just 4b. Okay? So far, so good? Now, reducing things, notice that these v's are going to be reduced away, canceled out. 4 divided by 2 is just 2, which is nice. And again, I could have got that just by doing that in my head, but I wanted to write it out just to make sure we're on the same page. Now over here, I could see that the 4v's are going to reduce out of this. So we're just going to have 6 plus 4v. Well, heck, that's a heck of a lot easier of an equation than what we started with, huh? This is a lot easier. So I'm going to subtract 6. I get negative 4 equals 4b. Therefore, v is negative 1. Now, I did tell you you want to check your solutions because now that we know that these equations exist, we should make sure that this is actually going to work, okay? So I'm going to put here check. So going back to the very top, this would be 1 over 2 times negative 1 equals 6. 4 times negative 1 plus 1. This is a negative 1/2. This would be negative 6 over 4, okay, plus 1. So we get negative 1/2 equals negative 6 over 4 plus 4 over 4. Zoop. Negative 1/2 equals negative 2 over 4. Negative 1/2 equals negative 1/2. All right, so it works. So we could say the solution set is negative 1. Okay. And again, a lot of times you're going to be able to do some mental math and be able to plug this in and just kind of do some of those number crunching things without paper and pencil, just be able to like see if it does work. But as you can see, it doesn't take much work to actually make sure that it works out. Okay. We're getting close to the end here. So now what we're going to do is solve a rational equation, just like that one, but it's going to have a quadratic mixed into it, and it's going to be in the denominator. I know, kind of sounds scary already, huh? But I assure you, it's not scary. We're going to be just fine. I promise. Trust me. So here we go. At first glance, yeah, it doesn't seem like something you really want to solve. but it's okay. Again, the goal is to try to get rid of the fractions, okay? And over there, we were able to do it by finding the least common denominator. Boom, you're done. I'm gonna do the same thing here, find the least common denominator. But notice that I have x's, I have expressions. So what do I do, okay? Well, think about it. This denominator has this factor, x minus 3. This has a factor of x plus 4. And then over here, it just has a quadratic. What I would recommend first is if you see something like this, factor the bottom. So a quick little factoring review. To factor this, because a is 1, I'm allowed to do it, what are factors of negative 12 that add to negative 1? Oh, sorry, not negative 1. I know, you can go ahead and complain there. Sorry, that should have been a plus. But negative 12 that add to 1. And the answer is negative 3 and 4. So this factors to x minus 3, x plus 4. Okay. Don't want my laptop to shut off. Minus 4 over x minus 3 equals 2 over x plus 4. Now notice something. X minus 3, x plus 4 appears in all of this. Okay? So if that's the case, that's going to be my least common denominator. Because think about it. What are multiples of x minus 3? So it'd be x minus 3, x minus 3, multiply them together, x minus, you just keep going. You don't want to do that. That's get messy. So what I can do is multiply the whole entire equation by these two factors, and that will get rid of our fractions. So let's take a look at that. So on this side, I'm going to multiply x minus 3, x plus 4, and then on this side, x minus 3, x plus 4. Okay. Now, I know it's kind of squished over here, so I apologize. But if I multiply these two things to here, and again, I'm not going to multiply it out because look what's going to happen. Okay? It reduces. They're all gone. All I have is a 7 that remains. Okay, if I multiply these two to this, notice, just based on this information, the x minus 3's are going to cancel. The only thing that's left is the x plus 4. So this will be minus 4 times x plus 4. And then on the right-hand side, we're going to do the same logic. So the x plus 4's here and here, they're going to cancel out. I'm just left with an x minus 3, so this would be 2, and then x minus 3. Now we're just going to solve this. 7 minus 4x minus 16. Be careful, there is a negative sign there. You want to make sure you keep the negative throughout the whole thing. And then 2x minus 6. I am definitely running out of space, so I'm going to go ahead and just try to write it up here. All right, so I apologize for that. So we get negative 4x, it would be minus 9 equals 2x minus 6. Again, I like to keep variables positive, so I'll add that over. Negative 9 equals 6x minus 6. Add the 6 over. Negative 3 equals 6x. X must equal to negative a half when you reduce it afterwards. Okay? And once again, we should check our work. And just like I said, for the timing of this video, it does work out if I plug it in here. But I want to throw a question your way. Okay? Let's say this is not negative a half. Let's say it came out to a different number. Well, look at your denominators here. Okay, what number do you not want to come up? Well, if x was 3, or if x was negative 4, I get zeros in the denominator, which we know is undefined. So immediately, I want to keep that in the back of my brain. I don't want those numbers to exist, okay? So when you're multiplying by these x values, you're essentially restricting the domain and saying that I can't have a 3 and I can't have a negative 4. If I do, this doesn't work out at all. And we lucked out. We didn't get a negative 4 at all. We got negative a half. So we could just say the solution set is negative a half with those brackets. Okay? All right. I got one more to go. I do have 2 more examples in my notes that I didn't get a chance to go over. If you want to look online for those 2 examples, you can. I'm trying to make this video as direct as possible. I don't want to fluff it up with a lot of examples. I want to make sure you get the gist and the basics of it. So I do, like I said, I have one more example with something like this, and then I have another literal equation example in addition to the one I'm about to show you now. So here we go. We'll put it on this board over here. So we're going to solve for m. Okay. It's a lot of variables. And I mean, that can be a little bit daunting at first, but I think we're kind of in our math career now that we're used to seeing equations or expressions or whatever with a lot of variables. So I don't think this is too much of an issue for us. It's just trying to figure out how to get m out of all this stuff. And here's the trick or the procedure, I guess you could say to it, but a lot of times what you want to do is whatever variable you want, try to get whatever has that term, m, to one side. So m's here, that's not good. So let's try and get m over to here, and then we might be able to manipulate something. So I'm going to bring rm over by subtracting. And then just to have terms with m on this side, I have to subtract cd over here. There we go. Okay, now, how did that help me? Well, look at the two terms here. Because they both have the same thing, I could factor out an m. So when I do that, I'm left with x minus r equals y minus cd, which is perfect, okay? So now, x minus r, it doesn't really matter what the numbers are, but when I do subtract these two, I get a number. Oop, don't want the laptop to shut off. I do get some number. So it's some number times m. What's the opposite of multiplication? Division. So what I'm going to do, I'll do it in a different color. I'm going to divide those sides by x minus r. Okay? It doesn't look like it's a different color. It's a dark blue. Okay? So my bad with that, I apologize. So we're going to reduce by canceling those guys out. So m is equal to y minus cd over x minus r. And you don't have to put parentheses there. If you do, no big deal. Okay? Now what does m truly equal to? Well, once you give me values for those variables there, then I can plug them in and tell you what m is. Okay? So there it is, guys. That is the very first lesson, linear equations and rational expressions. So hopefully this video helps, and I hope you're doing well today as well. And anyway, I'll see you all in the next lesson video.